Yeah, this is really messing up with my eyes. Yeah, I don't know if you can see or not. Don't look at it for too long, but if you do, I do see them immediately. There are some people can not see the little balls between the squares. They are not actually there. But there you go, you have a Python code to generate it on your own machine, on your own device. You have a bunch of other optical illusions. Yeah, so there's a bunch of things like that on the side, but there's some more serious things. More directly, well, everything is related to optical illusions, are related to biomedical data, because it's using your vision and your brain is tricking you with all sorts of things, silly things. So it is relevant to biomedical data that way. Yeah, I'm meant to be giving this lecture, I think tomorrow, to like 500 students from one of the universities I went to. It was 10 years ago. But then there's a YouTube channel, so you could just, so the students could, any students, if you have students and you like interesting content, well, first show them the website. Second, they can view the YouTube videos. Would the two things work side by side if I have another tool using the camera? It does work. I didn't expect that, because we have a third one. Actually, yeah, we actually have a third one. So this one does eye tracking, as the title suggests. You can change your parameters and things. The eye width, eye height, and the darkness threshold is we'll try and find the darkest point in inside the square, which will be hopefully your pupil, so you can use it as an eye tracker, and it's super cheap because professional eye trackers cost thousands, 10,000s, hundreds of thousands of dollars. This one you need to tune up to the light in the room. Will it detect blinks? It will detect, you close your eye, what is it doing? What is it finding a pupil still? Well, yeah, because that will be the dark point in it. But yes, you can adjust the threshold to make it work better. Essentially, if you're looking straight at the camera, your face is straight, it will be then working better. Actually, I had another one of those. We'll find if it works as well. I might crash my stream or something. It was also in simulations. We have this vision impairment thing. Vision impairment doesn't work. Yeah, it does. Yeah, now I can hear my CPU going. So this one mimic. It's a simulation. It's not real. To mimic different types of a vision loss or impairment. So you have peripheral vision loss, you have color, wait, no, sorry, that's wrong. So what's up with that? Okay, I'll put it that way. Yes, so you have your blur, your brightness, your contrast sensitivity, and your peripheral vision loss. What type of vision loss do you have, if any? Guess depends on your age. Yeah, there's a description at the bottom of which each parameter simulates. So you have things like myopia, hyperopia, and things like that, which cause blurriness, brightness sensitivity, contrast sensitivity, so on and so forth. and peripheral vision loss. Well, that's pretty much it. The color saturation doesn't work at the moment because the robot couldn't actually get the code to work. And I also don't know why this specific tool requires more. I can hear my CPU going, so that's probably not a fun thing to listen to. And if some of that noise gets into my speech as well. But yeah, so you have a lot of people talking about AI. Well, pretty much everyone is talking about AI. You have some people using AI. Some of them even do it properly. We definitely use a lot of AI, and we definitely talk non-stop about AI. But we're actually doing AI. So this is a EEG seizure detection algorithm using convolutional neural networks. So you can browse through the data. If you can spot the difference, I don't know if you can. Let me know if you can in the comments below. That's what most YouTubers say, so I have to say it because we are a good training model. Anyway, you can see this. Hopefully you can see this. Depending on if you have any vision loss from before, you might not be able to see it, but then you can use a convolutional neural network to actually look for it for you. So if you're an EEG technologist and you lost your eyesight, you might have to use a tool like this. So the dataset has training, test, validation, 600 images all up. You can scroll through them over here. Some of them have some weird noise. That's real EEG time series data converted into spectrogram. So converted into an image, because the neural net in this case is using image libraries and models to try and detect which image has seizures in them. So in this case, we did the training, 10 runs. 10 is not because it's a pretty number, it is a pretty number, isn't it? But 9 actually gave us better results. So let's actually make it a bit keep forgetting I have this super wide screen that nothing fits horizontally. Anyway, so what I was saying, so you can scroll through the data, all the images. There's about 600 overall, but about 30 in test, 30 in validation, and the rest are used for training. We're training a convolutional neural net. All the code is at the bottom of this page. So if you scroll down, you see the code. So to begin with, the first couple of trainings, we didn't get great results. No, actually, the first time around wasn't too bad. I don't know what something got stuffed up in the second one. We changed the parameters of the training algorithm. You get essentially the accuracy and the loss plots for each training run. You have your confusion matrix. All the misclassified images will be displayed on this canvas, and the training log, which has the accuracy, the training accuracy, the validation accuracy, training loss, validation loss, how long did it take to train, the final model size, which is important, especially if you want to deploy something in JavaScript on the fly or on your phone or whatever. We want to reduce that size of the model. Yeah, we can do later on. We might be doing other tools that are to do with parameter reduction. So if this model has actually found whatever gazillion of parameters, we want to actually see what they are and start getting rid of them one by one and see what difference does it make. Do you think it will make a difference? I bet it will. Well, we want to find essentially which parameters are responsible for most of the successful detection and which parameters are not needed. So we kept tweaking some of the parameters, and run 5 or started to receive some reasonable results. You have the accuracy going up and the model loss, the loss function going down, as you would expect. The blue is for the training set and orange is for validation, which is much smaller, but supposedly the validation couldn't actually find the information for it. We're essentially replicating results that were published a couple of years ago, and I think we did slightly better. I'm not sure. Maybe. Yeah, they did about 86% from memory. So with 86% test accuracy, you're getting essentially 4 non-seizure but detected seizures. So those will be false alarms. So when you have nothing but something is detected, so that will be a false alarm. This will be a false positive type 1 error. Yeah, double check everything I say. Same as with ChatGPT, you have to fact checked everything being said. And then we, in this run, we also had the 4 misses. So this is where when you actually have a seizure, but the model saying, I can't find any, what are you talking about? But that's wrong. Run 7, we slightly reduced numbers 3 and 2. You can see the examples over here. So this one is where the label is 1, meaning it is a seizure. So you can kind of see something there. Is essentially what you're trying to detect is this, and hopefully this is what the model actually learned. That's something yet to be confirmed, that actually to actually see how is the model doing it. So we don't just want it like a black box. We have all the code below, but we also want to test that what parameters is it taking into account and how is it actually making the decision. So if you treated the neural net as your expert, you want to actually learn and see what on earth this expert is doing and how is it, I should say it or they, make the decision. Do we need a music break? By the way, it's hard to point when you have, on this one, you also have the notes, so there's quite a lot to it. You have a musical note. You actually have 2 of them. So it's like playing 2 instruments or playing the piano with both keys. So you have, well, actually not, because they will have a different notes at different locations. So essentially 2 scales of notes. You have up and down, setting the volume, and you also have the length of each note, with this being shorter and pinching the fingers together makes the note shorter and longer. Yeah, whatever, it should make sense. It should just make sense. Famous last words. But shall we get back to which way am I pointing? It's the other way for me. Anyhow, so hopefully the model is actually trained to recognize this spiking. So if you look at your time series data, you will see a lot of spiking happening. And this is during seizure. And as the seizure progresses, the spiking rate, frequency rate is slowing down. So you get them, they become slower. So essentially what you're looking at here with that curve, and essentially that extra frequency component in general that you don't have in a non-seizure sample. Yeah, so in this example, run 7, the training, the eventual model misclassified a bunch of images, essentially misclassified 5 images. So 5 non-seizures, it said that 3 non-seizures were classified as seizures, and 2 seizures that were misclassified as non-seizures. So this is your miss, and this is your false alarm, which when training the model, the better the model is, the more of those you will have, and you will have more correct responses. And yeah, you have 30 of each in validation. So the confusion matrix is just using the validation, and you will have, for perfect results, you will have 30-30. So you have essentially 30 seizures and 30 non-seizures images like this. This is what the confusion matrix is showing you. So in this examples, yeah, what was I saying? I'm jumping around, sorry for that. Hopefully you can follow along. Don't forget to ask your questions. You can do it in the chat. If I don't see it during a live stream, you can always answer it next time, during the next stream. I'm trying to do most of my stuff online. Okay, so what did we cover so far? So I was saying, yeah, we're covering this EEG seizure detection project. It's up and running on the site. You can check the link. Should be everywhere, pretty much, on all socials and stuff. I was saying you can scroll through the data and see your accuracy, model accuracy and model loss functions. And we did 10 runs of training. Run 8 was even better than previous runs. We get up to test accuracy of 95 and no false alarms, which is great, and only 3 false negatives, so 3 misses. And yes, you can see from the misclassified images that it's actually hard, except this one. I would have expected the model to do that, was it second image correctly, because you can see something in there. The first and third, yeah, first has a lot of noise in it, so it's not surprising that we got it wrong. And the third one, yeah, you can't see much in it.